Okay, is everybody good so far? Does that fix some misconception?
Hold on.
Y'all good counting?
For the base area that y'all get, 0, 12.56, 113, and 201. Base area.
For what you want, bro?
All of, I just.
What is that?
No.
What is that? Sheridan, what's that?
Bro, I literally got this.
Not height.
Yeah, that's what
I went too fast, my bad. 12.56 for the first one, y'all got it.
You heard her? Sheridan, what's the X? Where'd you get that from, Sheridan? Where'd you get that from? Did you see it? Did you look at the table?
Miss Courtney.
Yeah.
113 point.
Okay, so work back.
Okay.
Yeah.
Think about,
I think it's 0.
no, because remember I was saying it's not gonna be 5 because we can't follow that pattern.
Yeah, we all got it.
But how did you get this?
Base area.
Okay, so could you set your base area times the height equal to 2,000 and solve for X? Think about that. Think about how you can set it equal to 2,000 and work backwards to solve for X.
Or if I 12.6.
Huh? You just.
Yes. Okay. Oh, so two spots after the decimal, so it'd be 12.55.
You gotta work back.
Or, I'm sorry, flex. There you go, 12.57. I don't know why.
We must run 2 decimals.
What you trying to get?
Yeah.
If it's 6.2,
Oh, that?
Work back.
you must run with next to 2. That would take
Which is whatever's after the 8, that's what you're looking at. What's the number?
So the 8 would make the 2.
Okay, so you're looking at the 3, is the 3 bigger than 5? Okay, so it's just gonna be 6.28.
So you must add
That's what I got right here.
Huh? So, just how we multiply to get the volume, you multiply the 2x times the pi x squared is your height times your base area.
How you make money there?
So,
And now we bought
did you get 1.7?
I was looking just like, what? Number.
Look, oh, you talking about, that's what you want.
Okay, so skip 10.
Like,
Okay, so yeah, except this is not 5, so you have to use this volume to figure out what the radius is. You gotta work backwards. It doesn't follow that pattern.
So, for this whole row, we're still using this?
No, so for these volumes, you calculate by multiplying height times the base area, because it tells you that here. The volume is the base area times the height, okay? But then down here, it gives you the volume, so you have to work backwards to figure out how we can find out what that radius would be if you had that volume.
So we know how we do volume.
this is a little box right there.
Okay, what's the book tell you how to calculate volume?
Well,
But does that make it a little easier for you? To call.
Wait, I did. So it says it right there.
He said, go ahead.
Volume equals the base area times height. So get your base area and your height.
2,000.
For volume.
Like 636. Then I did that, squared it off. Got like 25, something like that.
I'm going to radius.
That's what I'm doing. No, I'm doing the height now. That was
Yeah,
easy.
I can't work backwards. I'm gonna just go like this and keep trying to work backwards. Start at radius 16.
And then you square it.
Like for this one, Like, do 2,000
Mhm.
divided by 5, whatever I got for that.
Mhm.
And square one and have
Not working that.
So, okay, those are the right steps, but you're missing a few of them because, look, no, we're close. Okay, so volume is the base area times the height, right? Okay, so what is that in terms of like my x's? What's base area? In terms of x's. And then what's my height in terms of x's?
Knee slap.
8 didn't work.
Okay, and do I know what my volume is?
I got it.
I got
Okay, so solving this,
one.
you could,
The last.
so that would be, so when you said divide by pi, that'd get rid of the pi, right? Okay, and then you also divide by 2, you can divide by 2 pi, get rid of the 2 and the pi. So that would x would be left over here, so then to do that, you have to keep both sides. Which I know that's, you have to do each step, like, but like,
I'm finna try 20. Radius will be 10.
yes, because this is your x.
That's a lot. Oh, see, 'cause I know it was a 5. I think it was 7. So that 5 right there. Then it's gonna make that 3 go up.
What the backwards?
So you working on that.
I think it's too much already. One day from the girl.
Got
It's
the 5, but working for 6.
supposed to be 200. 10 times 200 is 200.
Oh, it was 4.
Everything's zero.
You're so sick. 10 times 8.
So we go to 6.28. No?
Okay, what questions do you guys have about calculating the base area?
No.
I thought we were rounded. You already rounded?
These are rounded, yeah.
Oh.
What's up? So to get, Caleb, I think you guys, I was just listening to y'all, you want to make sure when it's, you're squaring the x, what is x? X is the radius. So you're going to be squaring your value for your radius and multiplying it times pi. Okay? Then, how do you calculate volume?
Okay.
Base times base area. Height times base area.
Yeah, the base area times the height. Where's that come from?
The book.
The book. What? Okay. So, volume equals the base area times the height. Okay, but what, how can I write that in terms, wait, hey, I need everyone up here. Okay, my base area, I'm sorry, my volume is the base area times the height. How can I write that in terms of the radius? In terms of my x right here. Think about, so we wrote the volume for length times width times height. We had all h's in those functions. Okay, so this is gonna have all x's in it, obviously because everything's in terms of the radius now. Well, how can I write that to represent the volume?
Which one are you trying,
What's
you
your
talking about 2,000, right?
Well, so it would be what's going in this box. Because if this is gonna be pi x squared,
2x times pi x squared.
yes. Okay, so do you guys see where this came from?
Yeah.
Okay, so to get volume, we have to multiply our base area times our height. But our base area was calculated by squaring the radius and multiplying it by pi, and then we got our height by doing the radius times 2. Okay, so essentially, volume is going to be all those things multiplied together. Okay, what kind of function is height? How do you know that?
Straight line.
Okay, if we graphed it, it'd be a straight line. Also, what's the degree of a linear function?
2, 1,
Okay? Right, so think about what's the degree of the quadratic function?
2.
Okay? And also, so what function would base area be? Well, if I have a degree of 2, what kind of function would that represent? Okay, so I have a quadratic function. And when I multiply a linear times a quadratic, what's my product? A cubic. And what's the degree of our volume function here? Okay, well 3 would be the degree, making it a cubic function. Okay, so you guys see how rectangular prisms, we had to do 3 linear factors multiplied. Well, now we're multiplying a linear factor times a quadratic factor, which is still how we're achieving this idea of cubics. Okay, so now, are you guys to this point where you're trying to work backwards? Okay. So we're going to use this. Our volume is equal to all this. Remember we could solve this 2 ways. We could graph it and find our points of intersection, or we could solve it algebraically. So which would you guys like to see?
I don't know if it will work.
Algebraically.
Algebraically? Okay, so if we have it algebraically,
You should get a message. Yeah, see what it does.
Trying to do Wi-Fi.
okay.
I'll get on my laptop though.
So I'm going to go ahead and write our volume function right here off to the side. Because this is like always how you want to start is with the information that you're given. So if we're going to work this algebraically, what information am I given?
2,000.
Okay, so I'm going to substitute it in for what variable in my equation. Okay. So me and Keisha were talking about, I guess, a few different ways you could solve this algebraically, but you know, essentially keep that idea of we're getting x by itself, because what does x represent? Because once we solve for x, what is that going to tell us for our table? Okay, it's giving us the radius when the volume is 2,000. You guys see that? So that's why I only have x's in my equation. Okay, so if I want to start simplifying this to create, remember those ideas of using like the multiplicative inverse to create the identities. Okay, if I'm still trying to get x by itself here, what can I do to this equation? Okay, what can I divide? Okay, so I could divide the 2. Well, would I want to divide the x, or do I need to keep my x's over here? Okay, so, but also think about, instead of dividing, what's something else I could do? Okay, we can multiply by 1/2 on both sides, and that would cancel out the 2. That would create a 1 by having 2, like divided by 2 on that side. Okay, so I know you guys maybe aren't used to seeing pi up here, but remember pi represents a value. Okay, so knowing that, can I divide by it or multiply by its inverse? You said no. Yeah? Okay. So let's try that. By doing that, what am I going to be left with on the right side over here? So when I multiply 1 divided by pi, what's going to happen to this side? It's going to be, all I'm going to be left with is x cubed, because this pi divided by this pi, that creates a 1. So then I'm left with, okay, so if you said x cubed, you're right, but I'm going to go ahead and show everyone how you got that. I don't know who said that. Who said that? Tyre? Oh, well, Tyre can't talk. So, Okay, so we were left with x times x squared, right? So if you haven't seen how we got that x cubed yet, we were here, and then this was the last thing we need to combine on the right side. Does that make sense? Okay, so I'll go ahead and write that here. Okay, is 1,000 divided by pi, is that my radius? Okay, what do I need to do to find the radius? So we have to do the inverse of cubing it because it's already being cubed. So think about when something was squared, and what was the inverse of squaring? Square root. So we're cubing, we need to take the cubed root, which you guys may have not done too much in your calculators. So let me see what button that would be.
They would have to,
Or it's like the one right above.
the raise to, yeah, it'll be
Okay.
an option to do a.
So when you're typing in a cube root in the calculator, you're
You want me
gonna
to pull it
do.
up here?
Huh?
You want, just show 'em on here?
Well, I can't really see it.
Um,
I mean, okay, so like this little caret key, above the caret key, it shows you something like. Okay, so this means we're taking a root, and then whatever value you're putting in here is like the type of root you're taking. So we're taking a cubed root, what value do I need to put in here? Okay, and then what am I going to put underneath the radical?
1,000 divided by.
Okay, right, we're going to put 1,000 divided by pi. So the reason, I'll tell you guys, if it's just a square root, it's implied that we have a 2 sitting right there, and that's how you know you take the square root. Any other value to take the root, like you can take a cubed root, third root, oh wait, that is third, cubed root, fourth root, fifth root, stuff like that is when you have to put the number here. Does that make sense? Yes, so do you guys see, is this what you're getting your calculators? Make sure you know how to do this, please. It's the button right above that raised arrow. That's how we like show the exponent, I guess in other cases. Can you go back to the PowerPoint? Okay, so what does that mean? When my volume's 2,000, what's the radius? Okay, so now that I know what the radius is, can I use that to calculate the height in the base area? Okay, so y'all go ahead and do that real quick. Okay, so let's see. What did you guys get for the height of this one?
13.6.
Okay, 13.6. And what did y'all get for the base area?
145.26.
Okay, so how can I use this to check myself? Right, so I could try to recalculate that volume by multiplying these, and I should, when you multiply 13.6 times 145.26, you should get something very, very close to 2,000, but it might be slightly off because of some rounding we did, like in these steps, okay? But like as long as you're in that ballpark of being very close to 2,000, don't worry about it. Don't think you've done anything wrong, okay? So then in B, right here, it's asking us, how did you determine the volume when you're given the radius? Okay, so yes. Let me get a different color. So when you're given the radius, I mean, I guess you could just copy this formula down, because we will be using this. You need to know, like, how to use volume if you're given a radius versus, how do you use volume of a rectangular prism if you're given the height? Would you be able to do that? Okay, so this is, I'm not going to write it because it's down here, but.
Oh, okay.
Okay, and then what about C? Okay, so what did we have to do to find the base area and the height when we were given that volume? So we were given a volume of 2,000. How did I find the height and the base area when all they gave me was this?
You said the base area equal to the volume.
Okay, we had to set the volume formula equal to the value that it gave me of volume. And since the x represented what? Okay, so since the x represented our radius, I could figure out what that was to, what did we need the radius to calculate? Okay, so we're going to write all this down. I'm going to erase this column right here. So, given the value of volume, set it equal to so you were explaining that we solve for x, which is the radius, and then we used the height and base area formulas from there. Or equations? Okay, so Friday we worked backwards graphically. You remember how, and also today we worked backwards graphically by, we graphed our area function and we graphed a line and found those points of intersection. Okay? And then today, or I guess, the other thing we did today is, this is how you work backwards algebraically. Okay, so I want you guys to see the connections between these representations and how we could find them. We could find like both of our answers using different methods. Okay, so now